Hi, today we're going to talk about bonding. A chemical bond is a union between the electron structures of atoms. Okay, so the electrons are what we're going to really focus in on here. The three types of bonds that we'll be talking about are ionic, covalent, and hydrogen. Okay, so the first type of bond that we'll talk about is ionic. And you'll see in the word, we'll be dealing with ions. So ionic bonds are formed when electrons are transferred from one atom to another, forming ions. So basically we're just going to take two different ions, and just to remind you, ions are when the protons do not equal the number of electrons. And then you might also remember that they're charged. So if you have a positively charged atom, because it's lost an electron, that's going to be attracted to a negatively charged ion because now it's gained an electron. So when those electrons are passed from one to the other, then looks like a smiley face. But at any rate, the classic example for ions are table salt. Okay, so we'll see that in the next picture. Okay, so here we're showing table salt, NaCl. And sodium over here, the Na, is going to have an extra, it has this electron right here, and it's just way out here in the third shell, kind of all by itself. And shells are really happy when they can have 8 into a shell. That makes them happy. And so over here, chlorine is missing one, right? So if you count, we got 1, 2, 3, 4, 5, 6, and 7. And so chlorine would be really happy if it could gain an extra electron, and then it would be 8. And sodium over here then will be happy if it bumps down to that second shell, which will then have 8. So this electron is going to be transferred over, so we're transferring electrons. So sodium then becomes positive because it's lost its electron, so it has more protons than it does electrons, so it's positive. Chlorine now has gained an electron, and so now it has an extra negative electron, so its charge is negative. And so we have positives attracting negatives. Opposites attract. Paula Abdul has a song about it. You should look it up on Google or on YouTube. It's great. Okay, so check it out. Paula Abdul, Opposites Attract. Alright, so now that we know about ionic, where ionic bonds are transferring electrons, oppositely charged ions are attracting, now we'll learn about covalent bonds, and this is when the electrons are going to be shared between the atoms. So I always think sharing is caring, C for covalent bonds. Okay, so sharing is caring. The C in caring reminds us of the covalent, which starts with the C. Alright, so we can have single bonds if ever you see just one line between two atoms. That just means a single bond. There can be double bonds between atoms, and there can also be triple bonds. So that's just good fun knowledge. And that's just referring to how many pairs of electrons are being shared. So a single bond is going to share one pair of electrons, double bonds 2 pairs, triple bonds are 3 pairs. Here's just a picture showing you how chlorine and chlorine, and then we have, here's where we're actually sharing that pair of electrons. So we have a single covalent bond between 2 chlorine atoms, and it's covalent because they are sharing electrons. Alright, so covalent bonds are when we are sharing electrons. But as we know, sometimes in life things just don't, people don't share equally. It's a tragedy, right? So when some atoms, when they are sharing equally, we call that a non-polar covalent bond. But when the atoms are going to be shared unequally, it is said to be a polar covalent bond. So I came up with a way to help us remember the difference between nonpolar and polar covalent bonds. So just kind of bear with me as we go through this little story. Alright, so let's say you and some friends are visiting the North Pole, and you get lost from like your tour group. So you're in survival mode, right? So you're like wandering around, maybe you make yourself a cave or something. And so when you and your friends, okay, so here's a picture of all your friends, right? So when you and your friends are all together and there's no polar bear, you're going to share the fish that you've caught. You're going to share all of the fish equally amongst yourselves, right? So it's kind of like sharing pizza equally amongst yourselves, right? So when there is no polar bear, when it's non-polar, that means that there is equal sharing. Because you're friends and you care about each other and you want to like share everything equally amongst yourselves. But when the angry polar bear comes knocking on your door, right, or in front of the cave, or the polar bear finds your cave, right, and comes in, and the polar bear is hungry and wants all this fish, and so you and your friends are like, oh my gosh, we don't want to get eaten, so quick, give all the fish to the polar bear. And so all the fish get tossed to the polar bear. Oh, wrong guy. Come on. Okay? So all of the fish are going to be thrown to the polar bear so that you and your friends, maybe sitting in this little igloo, are not eaten by the polar bear. So in essence, the polar bear becomes a big hog. It's not sharing equally, all right? So when the polar bear is around, it is unequal sharing. So does that help? So think, when the polar bear is around, the polar bear is hogging all of the fish, okay? It's unequal sharing. But when there's no polar bear, okay, when there's no polar bear around, then everybody is sharing equally and we're all smiles. Okay, so hopefully that helps. All right, when we have polar bonds, we're going to find that there's a slight difference in charge between the two poles of the bonds. So electrons are negative, and so wherever there's going to be more electrons hanging out on one side, then we're going to see a slight negative charge. And on the other side, we're going to see a slight positive charge. And we see that for sure here in this molecule of water, H2O. We have a slight negative here, and we have slight positives where the hydrogens are. And that just means oxygen is a bigger atom, it has more electrons, and so the electrons, which are negative, will be hanging out at that end. Again, we're just reiterating that water is an example of a polar molecule because there's an uneven distribution of electrons between the hydrogen atoms and the oxygen atom. So they're sharing electrons, so that makes it covalent. It's just that they're sharing the electrons unequally, which makes it polar covalent. And this leads us to our third and final bond that we're going to talk about, which are hydrogen bonds. Hydrogen bonds are best explained when we look at an example. So when we look at two water molecules, that's where we're going to see hydrogen bonds. So the bond that's going to hold the two different water molecules together is going to be a hydrogen bond. So the hydrogen atom of one water molecule, which is going to be slightly positive, is going to be attracted to the oxygen of another water molecule, and that oxygen will be slightly negative. So the force between the two different water molecules, we're looking at the hydrogen of one water molecule is going to be slightly attracted to the oxygen of the different water molecule. And that type of bond we call a hydrogen bond because of that hydrogen that's involved in one of the water molecules. For me, pictures always help explain things and make everything make more sense. So hopefully when we're looking here at the picture, so here's one water molecule, right? It looks like an upside down Mickey Mouse. So the ear, which is one hydrogen atom, which is slightly positive, is going to be attracted to a different Mickey Mouse, right? So the chin over here, which is slightly negative. And so that slight positive is attracted to this slight negative over here, and that because this is a hydrogen atom, we call that a hydrogen bond. Okay, so don't ever get confused. Within one, water molecule between one Mickey Mouse, we have a covalent bond that attaches the ears of Mickey Mouse to its face. So that's a covalent bond right here, but it's a polar covalent because the electrons are being shared unequally. But between two different water molecules, we're going to see hydrogen bonds. All right, so that's our lesson on bonding. I hope that helps. If you have any questions, make sure to ask. And Jesus loves you.